In the past, lecture or discussion, we talked extensively about lists, how to create lists, how to work with lists, how to manipulate elements within a list, how to slice and dice, lists. But for today, we are going into if statements, which can help you automate different elements of your program, and eventually you're going to see where lists actually features in the whole construct of the if statement. Because in some cases you can actually use an if statement to all of a sudden now go into a list and perform certain operations on the key elements, various elements within the list. Well, before we dive into all of those, what I'm going to do is talk to us about the if statement and the different control elements within Python. So, and the key learning objectives for today will be: number one, understand conditional statements. We understand the Boolean expressions, and the Boolean expressions are usually something like, think of the bulb switch in your house. It can only do two things. It can only turn on and turn off. I mean, I know there are those that can graduate the intensity of your lights, but those are not the ones I'm talking about. I'm focusing on those switches in your house that you can only turn on or off. That's an example of a Boolean expression, right? Something can either be true or false, yes or no. That kind of operation does exist in Python. So the next thing we're going to focus on is the if else, and if else if logic, right? We're going to look at each of those, and then we are also going to use logical operators to perform some of those conditional expressions, and then we would apply conditional tests in some real program. That will be the focus of today's class or discussion. So conditional statements are programming structures that allow a program to make decisions, like I mentioned before, and it actually helps execute different blocks of code depending on whether a specified condition is true or false. So that's what your conditional statements generally are and what they do. Now, they also control the flow of a program, and they do that by evaluating the Boolean expressions, which I just mentioned right now. So what you're doing is essentially a logical test. If something is true, then you go in this direction. If something is not true, you go in the opposite direction, right? So essentially, a lot of things around your conditional statement involves making decisions, and those decisions are used. You can make those determine or make those decisions using Boolean expressions. And now it helps you determine which of the instructions should run. So when you have conditional statements, and I'm going to show you the syntax of typical conditional statements, you need to be able to come up with some conditions and then determine, use Boolean expressions to decide whether those conditions are true or not. And if they are true, one action is taken. If they are not true, another action is taken, or no action is taken at all. So this is a typical example of what I refer to here. Let's say we have a temperature, that is set at 85. So what this particular conditional statement is saying, if the temperature is greater than 80, then, your computer prints out it's a hot day, right? If it's greater than 80. Else, anything lower than 80, it says the condition is moderate. So in a situation like this, we already know that the temperature is 85, right? So we run a check. If the temperature is greater than 80, in this case, it's true. So what it does is it prints, it is a hot day, and it doesn't execute the next line of action else, because there's no else right there. And then it just prints that, But if temperature is less than 80, it's going to ignore the print it's a hot day and then go execute else. the temperature is moderate. So these are some examples of comparison operators that you're going to see in some of the codes we are going to be running today, where you're going to have your equal to. So just using one mathematically, right? The equal sign in Python is not quite what it is in the equal sign that you see in mathematics is not what it is, right? In mathematics, what you use as equal sign in Python is used as equivalent to. But if you are actually looking at saying something is equal to, it's actually double equal sign. So which is what we have here. And if you're trying to say something is not equal to, you have that column and equal sign, and that's what actually says that something is not equal to. So these are some of the conditions that you find yourself testing in some of these conditional statements. You also have your greater sign, and these are all signs that are familiar to every one of us because at some level we have done some kind of mathematics. And then this is your greater than or equal sign or less than or equal sign. So, and this is an example of your Boolean expression, right? What it could evaluate to. Let's say we have an example here where we say 5 is greater than 3. Is 5 greater than 3? Yes. In other words, that's true. It's a true statement. So if I use this as an expression, then this is true, and then a particular statement will execute. Look at another one. I could have multiple users where one of the users is admin, the other one, John, Peter, blah, blah, blah. But each time what I'm trying to say with this statement, I would say if the user is admin, right, then give them access, right? So if at any time the user is anything but admin, it becomes false. The only condition under which user it becomes true is when user is equals to admin, and then in that case it's true, and then the next statement executes. This is another example. If someone's age is greater than or equal to 18, then in other words, if it's 18, 19, 20, 21 to infinity, that's a true. But anything lower than, if this is not true, this statement is not true, then it's a false. And we're going to see examples of all of that if it's not still clear to any particular person. So commonly implemented. So conditional statements are commonly implemented with these particular constructs like the if. This is elif, which is technically else if and else, right? And we're going to see the different uses of this, right? They enable programs to respond dynamically to data, user input, or changing conditions. So remember when we did user inputs, right? There are times when the system will prompt you to give some kind of information, right? So for example, it could say user, and then it will prompt you to give the user, you give the user, and it will go test it against something. And if that thing doesn't, it becomes a false, then it does not implement. If it's a true, if that user that you have given is equivalent to the user that it's expecting, and then it's a true statement. So we're going to start with the if statement, right? So the syntax for the if statement starts with the if keyword. It's followed by some kind of condition and ends with a colon. So that's what the syntax is. And it's important whenever you're working with any conditional statement, if you can't remember or you don't know what the the syntax is, just go online and type if statement in Python, and it will you say if statement syntax in Python, and it will just give you what the syntax is, and then that can guide your programming. So, and then the code to be executed is usually placed in a new indented block. And we're going to see what that is. You have to indent it under the if statement, right? Because that's how you know that the if statement is supposed to be, that condition is going to be executed under that specific if statement. And we're going to see examples if this is not very clear to you. So this is an example, right? So notice that there is an indentation going on here. And usually the point from here to here This is a line. Indentation is really important in Python. Normally, it's going to be like four space bars, or you use your tab. Usually, it's your tab. You can see it on the left-hand side of most keyboards, right? If you click tab, assuming the statement was at the same line with this, you click tab, it would move 4 spaces in here. And the idea is to say that everything under here is, subject to the conditions imposed on by this if statement. Notice that once you execute this, the next non-indented statement continues normal program flow. So if I wanted to put in some kind of program to be executed that must not be governed by the rules, right, instantiated by the if statements here, then I make sure that that line is on the same line with this. Again, we are going to see examples, and I hope to point those out when we are going through some examples. So this is an example. Let's assume someone's age is 42, and then we are trying to write a program like this. This is an example of an if statement. If the age, remember this is greater than or equals to. In other words, it has to be 18 or more than 18. And remember your colon. So if age is greater than or equals to 18, then do this. Now, because both of them are, you know, are subordinated under this if statement, what it's going to do is that, so since age is greater than, so the point is, what is age? Age is 42. So you're saying that 42 is greater than or equals to 18, which is true. Then it's going to print this line and print this line. So that's an example of an if statement. And then you have your if-else statement. Now, the if-else statement, right, provides an alternative block of code to run if the initial if statement evaluates to false. Let me go back here and try to explain that. So we already have a situation where this is true. What if it is false? Where, for example, the age was 12, and then that means 12 is greater than or equals to 18 is false, right? Then this program stalls. It doesn't know what to do anymore. Under those conditions, under the next under the if-else statement, right, it actually gives you an additional condition here. If this is false, then else, then do something else, right? And that's what the if-else statement provides you, the opportunity it provides you. So that's why it says the else statement provides an alternative block of code to run if the initial if condition evaluates to false. Now, the else condition does not require a condition, right? In the first case, you have to create some kind of condition, but the else case does not necessarily require a condition and must be on the same indentation level as the if statement. Why is it important that it's on the same indentation level? If it's not on the same indentation level, then everything in if actually applies to it. But because you want to get it to do something, since this evaluates to false, it needs to be on the same indentation level as your if statement. Any questions? So this is the syntax of your if-else statement. If, and then you introduce a condition, right? Tina, yes, go ahead. Ask your question.
What is the difference between those booleans and those conditional statements?
The difference between the booleans and the conditional statement. So the boolean, so let me come in here. So this is your conditional. So this is your what do you call it? The condition, right?
Yes.
The condition evaluates to a boolean, because all a boolean is yes or no, right? So it's almost like the difference between saying 2y is equals to 2x plus c. They are the same thing technically, right? But you know that y stands on its own. Y is the output of this input. right? So you have those
Mm.
conditions, but then what it evaluates to is the Boolean. And it's the Boolean that actually helps make the decision about whether we go forward or we go backwards, or we don't go anywhere
So,
at all.
so
Yeah,
are
go
they
ahead.
one and the same thing? So are they one and
Technically,
the same thing?
they are equivalent to each other, but they are not one and the same thing. They are equivalent to
Oh,
each
okay.
other. Yeah, yeah. That's why I use the y is equals to 2x plus 3. Y is equals to 2x plus 3. They are equivalent to each other, but they are actually different things because y is your output, but 2x plus 3 is your input. Make
Okay.
sense? Yeah. But
Now,
the yeah, go ahead.
yeah, I'm kind of lost. Can you please elaborate on that?
Yeah. Okay. So just hold that thought. We are going to go into the examples and I will show you a couple of things. Okay.
Okay, thank you.
All right. So if example, so if then we create a condition, and this is a code, a line of code that you put in here. So if this becomes true, if this condition equates to true, right? If this condition equates to true, then do this. Else, if it doesn't equate to true, then do that. That's your if else statement. And I'm going to, again, to the point, I'm going to go show us examples. So look at this, right? So Tina, look at this. So 2 is equal to 0.
Yes.
If yeah, if a certain number, right, you apply this to the certain number, right, is equal to 2, then the number is even. I think this is the modulus operator, right? Somebody, this should be the modulus operator. And I think how the modulus operator operates is the remainder. Let's say 3, if this number is 25, right? 25 divided by 2, right? If 25 divided by 2, what is it going to give us? It's going to give us 12,
Of remainder
correct?
one.
Remainder
Yes.
1, right? So that remainder 1 is what is going to land here. Make sense? So that's what the modulus operator does. If a certain
Okay.
number, so for, yeah, so if we say 24 divided by 2 will give us 12, remainder what? 0. So this will be
Yes.
0. So for 24 is even. The number is even. But for 25, this is going to evaluate to false. So to your point, if the number and then I apply the modulus operator by 2 is going to give me this, right? So this is my condition, right? But it's going to evaluate to something. Now, if I apply this modulus, this equals to 0, is that true or false?
False.
False. So false is my Boolean operator, right?
Okay.
Because Boolean is just positive or negative, 1 or 0, true or false, right? But this expression here is my condition, right? But it's my
Okay.
condition that is going to determine what the Boolean value will be, whether it will be true or false.
Okay.
Uh,
So
mhm. Go
so
ahead.
you mean the condition is the input, the boolean is the output.
Correct. That's my point. Yeah.
Okay. 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 I
Yeah.
get it.
But yeah, so unlike a light switch, right? It is that on or off that will determine what happens, right? That on or off is what will determine whether we go ahead and print or we don't print. So if you tap your bulb switch down, let's say the down is off, what's going to happen? It will trigger the bulb to go off. If the condition now goes up, the bulb comes on, right? So that's what's happening with this. So next, then we also have if else if else. That's it begins to loop through, and when we go through the examples, you are actually going to see how this is implemented, in our study text. To check multiple conditions sequentially, now you're going through multiple conditions, right? What if we go through one condition and it's not true, and then we go through another condition and it's not true? Then how do we play it, right? And that's when you begin to use your if else, right? So in this case, Python checks each condition in order, and the first block with a true statement is executed. If all the conditions are false, the else block, if present, runs. So you're going to have your if, elif, and you can have 1,000 elifs, and then finally it's going to end with else, right? So, and you're going to see this is what the syntax would typically look like. Again, for any of these statements, right, you want to go check, you can always go online and just type if else statement in Python, just say plus syntax. It will just show you what the syntax is, and that's exactly what it's going to be. So if I had a condition 1, if I apply this condition and it says it's true, then it will print. But if it is not true, it will go to the next place and try to see if it's true. If it's still not true, it will go. But if at any time it becomes true, all the other lines are not going to run, right? But it's going to continue that until it gets to a point where it exhausts all the options, and then you say it's false, and sorry, we can't do anything about it. So this is a typical example, right? Now, the score, let's assume we have a random score somewhere that is 85, right? And think of it, this could be a whole list of scores, right? It will be scores equals to square bracket open, and then you list different scores of students. So this is a situation where you're trying to write a program that can assign scores to all of your students, right? So this is the first element, for example, in that list. And then you write a code like this, right? For each of them is going to literally print what their score is. So for this person, particular element within that list, you say if the score is greater than or equals to 9, print A. Obviously, this is false because it's not greater than or equal to, so it's going to skip this and not do anything, and it will go to the next one. Else, if the score is greater than or equal to 8, which evaluates to true, and then it will print grade B for this particular student, and then it will stop. For others, it might run, because this person does not even get greater than, gets much lower than greater than or equals to 69. Let's say the person 70. Let's say the person got 68 or 69. It's going to evaluate because it has tried all of this. It doesn't work. It's just going to say, hey, this guy made an F, and print out F for that particular student. So the key takeaways for this is that conditional logic drives decision making. It can actually help. That's your way of automating some of the decisions you want to make within a Python code. Then Boolean expressions are the things that actually power the program logic, and it's essential for building, intelligent programs. Some of those statements like your if else, and all of that. And then some important things to note: indentation is often required. It defines the code blocks. The standard convention is 4 spaces or a tab on your keyboard, which is what I was showing us. So each time you do an indentation, just place the cursor by the side of that word and then hit your tab function. It will shift it 4 spaces. Now, the condition, this is, I guess, what Tina was talking about. Use comparison operators such as equal sign, not equal, greater, less than, greater than or equal to, all of that. Those are some of the conditions that, some of the comparison operators that you can use within your conditions to determine what your Boolean will be. And then you have your logical operators too. And I think in some of the examples we are going to look at today, you see some examples of logical operators.